In this question, it's a nice challenging question, and it really pushes you to see if you understand these ideas. So we have the given functions f of x and g of x, and we're asked to find f composed with g and g composed with f, and then give the domain. So f of x equals the quantity 1 minus x all divided by 2x, and g of x equals the quantity 1 all divided by 1 plus 2x. And you can see that I've tried to use color coding here to help you. So f composed with g means f feed in g. G is closest to the x, so that's what gets fed in. So everywhere you see an x in the f of x formula, you need to put g of x instead. So I have 1 minus g of x in the numerator, all divided by 2 times g of x in the denominator. And that is going to give me 1 minus 1 all over 1 plus 2x, and I'm going to put that in parentheses, all over 2 times 1 over 1 plus 2x, so I'm going to put that in parentheses. And now I'm going to have to deal with the numerator and the denominator separately. In the numerator then, I have 1 plus 2x, because I'm going to get this all over the same denominator, subtract 1, all over the denominator, 1 plus 2x, and in the bottom I have 2, I'm going to make that a quantity, all over the denominator, 1 plus 2x. You see where I got that from, right? This is 1 minus 1 over 1 plus 2x, and now I have to find the least common denominator, and of course that's going to translate into 1 times 1 plus 2x all over 1 plus 2x minus 1 over 1 plus 2x, and that's how I get this line here, and that will enable me to get a common denominator. So I'm just going to deal with the top of the complex fraction first. Positive 1 minus 1 is going to give me 0. So the top of the complex fraction will be 2x, all divided by the quantity 1 plus 2x. And the bottom of the complex fraction will be 2, all divided by the quantity 1 plus 2x. Now remember, when I have a complex fraction, I'm going to multiply by the reciprocal. So I have 2x all over 1 plus 2x, that's my numerator of the complex fraction, multiplied by the reciprocal, so that's multiplied by 1 plus 2x all divided by 2. So now I'm looking for factors of 1. I always tell students, don't cancel, that messes with your brain. You're looking for factors of 1. That's what cancelling really is. So this and this are a factor of 1, and 2 divided by 2 is a factor of 1. So that leaves me with x. So what I just found was f composed with g of x equals x. Next we're going to find g composed with f. F is closest to the x, so that's the function that is fed into g, which is on the outside, furthest away from x. So g is 1 all over 1 plus 2 times f of x, because that's what we're feeding in, and that is going to give us 1 in the numerator, all over 1 plus 2, and now I've got to put f in here, so that's 1 minus x all over 2x. And I'm going to have to simplify the denominator, so that's 1 all divided by, I'm going to write it like this, 1 plus 2 times 1 minus x all over 2 times x. Because then you can see there's a factor of 1 right away. So this is going to actually result in 1, and then all over a complex fraction in the denominator. That's just the quantity 1, and then plus the fraction 1 over x divided by x. So I need to get this all over a common denominator. So this is x over x plus 1 minus x all over x in the denominator, and that's the denominator. 1 is in the numerator. So I know that x minus x is going to sum up to 0. So that gives me 1 all over 1 divided by x. Now, of course, I've got to multiply by the reciprocal, so that's 1 times x over 1 multiplied by the reciprocal, or x. So I have just found that g composed with f of x is x. Next we're asked what is the domain of f composed with g? That is the intersection of the domains of the result of the f composed with g and the domain of the input function, which in this case is g of x. So the domain of just the function x, so now we're just thinking of f composed with g as just x, is all real numbers. And the domain of g of x, well, remember g of x is 1 all over 1 plus 2x. So we have to figure that out, because whatever that is going to be the domain, because the intersection of the domain of g with everything is the domain of g. So what we cannot have in the denominator, divide by 0. So we cannot divide by 0. So 1 plus 2x equals 0. So that means 2x is -1. And if I divide both sides by 2, x equals 1/2. So that's what I cannot have, actually. None of that is allowed to be true, otherwise I'm dividing by 0. So it's every real number except 1/2. If I was going to put this on a number line, here's my -1/2. I cannot have that, but I can have every other real number below -1/2, and I can have every other real number above -1/2. And that is this. So if I'm going to write this in interval notation, it's -∞ up to -1/2, and these parentheses mean go all the way up to -1/2, but don't actually go to -1/2. Anytime you see this union symbol, it means there's a gap, and then start again at -1/2 and go all the way up to +∞. So that means we could get to very, very infinitely close to -1/2, but we cannot be -1/2. Now we want to find the domain of g composed with f. So we have to find the domain of the result of g composed with f and find the intersection of that with the domain of the input function, when in this case that's f. So the domain of g composed with f is just all real numbers, isn't it? Since g composed with f is just x. So really what we have to do is we've got to find the domain of f. And the only thing that would kind of mess up f is I cannot have a divide by 0. So 2x is not allowed to equal 0, so x can't equal 0. So if I looked at this on a number line, here's 0. I have to exclude 0, but I can have every other number on the number line except for 0. So that, in interval notation, is going to be -∞ up to 0, u, which means a gap. I think of it as union gap, divided, comma, +∞. So this is an interval notation that describes this picture right here, everything except 0.